just because everything that could go wrong is going to go wrong, and I don't have my best equipment here. Okay, so find the phasors for VS, I, VR, and VL. What is the phase relationship between VS and I? So everything that you learned in circuits 1, you get to use again in circuits 2, but now we're going to apply it to AC circuits. So the first thing we can do is find the phasor for VS, and VS, the phasor for VS is the magnitude 10 angle. Now on this one, there's no plus or minus degrees in there, so it's 10 cosine 500t plus 0 degrees. So this is angle 0 degrees. And then that 500 in front of the t, that's omega. So our frequency is 500. Now, so this is the phasor for VS. Phasor for VR, though that's the voltage across there. So the resistance, when I cast everything into the phasor domain, this becomes 10 angle 0 degrees. And how do I put an inductor, how do I write an inductor as a phasor? Just so I know somebody is there, at least just say an inductor.
An inductor?
Okay, great. Excellent. Okay, so for an inductor, to put an inductor as a phasor, that's J omega L. And
Okay.
so you take your inductor, and that's going to be J times omega, which here is 500, times the inductance, which is 0.2. Since I don't have my calculator out, that's 2 over 10. So that turns that into 50, so that turns that into J100. I do have my solutions here on my phone because the printer in the library is broken, but do keep an eye on me with the calculations just in case I make a mistake. Okay, so that means that we have now a circuit that in the phasor domain looks like this. And the resistor stays the same. That was 100 ohms. And the inductor is J100. And once you put everything into the phasor domain, they add and subtract like resistors did in circuits 1. And so these two are in series. And so they just add together to get our total impedance is 100 plus J100. Now, you might notice that that means if you were at my session on Tuesday where we talked about complex numbers, that the real part and the imaginary part are the same. So that means that this is going to be at an angle of 45 degrees. And so this phasor, I could change it into phasors just by doing the following. I can take 100 plus, and then the J is the I right there, 100 plus J100, and then second in complex, and the number 4 is to change to polar, and it gives it to me as 141.42 angle 45. But I knew it was going to be an angle of 45, and then also since both of these, this would make a right triangle, 100 by 100, this would be 100 times the square root of 2, so that's why that's that is the square root of 2 times 100, so 141.4 angle 45. Okay, so that's our impedance. And so I went ahead and changed that to polar. I'm already deviating from my notes because then I realized it was not hard to change to polar. And if you remember from circuits 1 that V equals IR, the same is true with AC, it's just V equals IZ. So if we're looking for I, we get V over Z. And so if I have V over Z and my V is 10 angle 0, and my Z is 141 angle 45 degrees, I can do that easily either using the complex capabilities of the calculator or not, because since they're both in polar form, then to do this without using the complex capabilities of the calculator, I would just do 10 divided by 141 equals 0.0709 0.0709, and then my angle would be 0 minus 45, or negative 45 degrees. And if I didn't want to do it like that, since I have my calculator, I can just do fraction, and then in the top 10. I don't have to put angle 0 because putting nothing is the same as angle 0, but 10 angle 0 over 100 angle 45. And I have my calculator set to rectangular, so then I'd go to complex and change to polar, and I get, looks like is that rounded?
Yeah, they rounded it.
Okay. Why did it round it that much? Let's see. I don't know. I don't know why it didn't. Let me see how I have my calculator set. No. I think I did something wrong. What did I do wrong? Oh, I divided by 100 instead of by 141. That was what it was. Okay. So what I should have done was 10 angle 0 divided by 141 angle 45. And then change that to polar. And there I get it. And it's saying negative 45, and that's right. So that's the same thing we got, 0.709 angle negative 45. So you can see that, like with what I did right there, it was useful for me to know two different ways to do it because I could check my answer. And when I got a different answer, I was able to figure out which one was the wrong one. Okay, so now I know that that's the current. And since it's in series, it's the same current through everything. So if I wanted to find VR and VL, then I'll just use Ohm's law again. So VR equals the impedance of the resistor times the current, and VL equals the impedance of the inductor times the current. So the resistor is 100, If I multiply that by 0.0709 angle negative 45, I will just get 7.09 angle negative 45. And that's going to be in volts. And by the way, make sure you put your units. The current would be in amps. And then for the inductor is J100. So J100 times 0.0709 angle negative 45. And you can do this on the calculator as it is. So I can do J100 times, so I can mix them, second complex, J1 times, open parentheses, 0.709?
Yeah. No, it's 0.0. Yeah.
0.0709.
Yeah.
Second complex angle negative 45. And then if I change that to polar, I get 7.09 angle 45. Now, another way to do this, if you remember J100, that's purely imaginary. So that is angle 90. So this is the same as 100 angle 90 degrees. And 100 angle 90 times 0.0709 angle negative 45 degrees, you multiply the numbers, so that would give us 7.09, and you add the angles, and that would give us a positive 45 degrees. And that would be volts on that one. Okay. So that gives us the VS, I, VR, and VL. And now it asks us the relationship between VS and I. So VS was 10 angle 0, and I was 0.0709 angle negative 45 degrees. So what they're asking for that is it leading or lagging? And so the current is negative, so you would say current lags voltage by 45 degrees. Does that go along with Eli the Iceman? So what does this mean? E is another symbol for voltage is EMF. So the E is for voltage. L is for an inductor. And I is for current. And this I is current. And the C is for capacitor. So I don't find this helpful because I still don't know, I still lose track of, like what, okay, so then what? So, but this is telling me that the voltage comes before the current in an inductor, or the current lags the voltage. So the current lags the voltage with an inductor. And that's what I have here. So I've got an inductor, so the current lags. Okay, so I'm going to pause for a second. I'm going to stop the recording, and then I'm going to see if anybody has any questions.